Hello YouTube. Today we're going to be analyzing a circuit and trying to find the voltage and the current and the equivalent resistance for this circuit here by using a bunch of techniques. So let's take a look at it. So first we're going to start off with superposition, and superposition is where we look at each of the sources and analyze the components of the current, voltage, and resistance, and then sum them together. So for voltage, we're going to look at this source here and this current source here. So for superposition, when you remove a battery, it becomes a perfectly conducting wire. So that's that purple part there. And I just labeled that open circuit there VOC1 for open circuit. So that's what superposition does. You take the battery out, you leave one source, and for when you remove a battery, you put in a perfectly conducting wire. So we can find, we can see what by removing the current source this time and leaving the battery. When you remove a current source, it's as if you're making an open circuit. So it's just like literally completely removing the current source and nothing happens. So it's just like drawing the circuit without the current source of 3 amps there. So I'm going to label that open circuit there on the left VOC2. So now we have two circuits and we can solve for the voltages for each one. So for the voltage across, real quick. So the true voltage for the open circuit in the original problem is the sum of VOC1 and VOC2. And this is what superposition does. You isolate a problem by breaking it down into multiple circuits with one source, and then you sum your results together. So for this one, we know VOC is actually going to be equal to 1. Now, why is that? Well, if you notice, when we remove the battery, we got a perfectly conducting wire there. So all the current is going to go through the path of least resistance. And in this case, we short-circuited that part of the circuit on the left. So no current will go through that 4 ohm resistor there on the far left. So therefore, no voltage will be across that open circuit there. So that's VOC1. Because as a popular phrase in pop culture is these days, taking the path of least resistance, following the path of least resistance. So this is it in circuits, where it really came from. So now let's look at the second problem. Here on the right, we got rid of our current source, but what is VOC2 now? Well, just using Ohm's law, we got I equals V over R, or excuse me, my apologies, I was thinking something else. So if you notice, this 8 voltage battery is in parallel with that open source, the second one there. So they actually have the same voltage. It's really cool. If a battery source is in parallel with an open circuit, then that means the voltages across them are the same. So that's something to kind of pick up on. So then the sum of V1 and V2, 0 plus 8 is 8. So the true voltage across the open circuit there in the original problem is 8 volts. Now what about current? So what we're going to do is when you're looking for current, you short circuit each part of that open voltage there. So we're going to literally take these two problems and just draw a line down to connect the circuit and short circuit the system. So here's the original problem, or the one on the left where we remove the battery, and that purple represents where we remove the battery and we put a perfectly conducting wire. Now we're going to short circuit it by putting a wire there as well and try to find the current across that part of the circuit. So that's going to be 0. Same reason as last time. Follows the path. The current follows the path of least resistance. It will not flow that way because the purple wire that we put in replace of the battery short circuits everything to the left of that circuit because we extracted the battery. So we know the current flowing through that part of the circuit is 0. Well, what happens when we remove the current source and we leave the battery? Well, again, we have that open source or circuit on the left. So now what we're going to do is we're going to short circuit it, and we're going to close off to make it a complete circuit now. Instead of we're not finding voltage, we're finding current. So what we do is we just solve this problem by using Ohm's law. So the current is equal to V over R. In this case, the R is of 4 ohms. So we got 8 volts over 4 ohms, and that gives us 2 amps for the current going through that part of the circuit there. So all we got to do is to find the total current for the original problem here from the short circuit. Would be the sum of the short circuits for each of them. So we'd get 0 plus 2 is 2 amps, and that is how you do the current part. Now what about our equivalent, or the equivalent resistance? Well, all you gotta do for that is deactivate your sources. So we got rid of the battery in the, there. That's normally the purple wire would be going vertical down there, and we got rid of the current source, which is literally completely scrapped. So we just have the resistors. So what does that look like? Well, let's reduce it down. We got two resistors in series of 4 ohms each, so we sum them together. 4 and 4 ohms make 8 ohms. And then we have two resistors in parallel, 8 and 4 make 4. So that's how we got the equivalent resistance. So bam, we figured out each section of this circuit. We found the equivalent resistance, we found the current that is short-circuited, and we found the open circuit voltage for this circuit here. So when finding the voltage, all you do is you do superposition pretty much, and you look at the open currents and you solve for each circuit. Same thing with current, except instead of leaving it an open circuit, you actually make it a short circuit and you close the circuit, and then solve for current, and then resistance is what you normally do when finding our equivalent, is reduce it down to a single resistor. So I hope this problem helped. It was kind of a cool problem to take a look at, and good luck and happy studying.